Hello friends, we will be learning integration today. We will be learning indefinite integration. And while we learn this topic, because the vastness of this topic, our pace of solving will be a little high. Let's start with indefinite integration. To understand this topic, let us recollect what we have learned in derivatives. Let us consider that we have d by dx of a function f of x plus some arbitrary constant c. Then the derivative of f of x is denoted as f dash x plus constant's derivative is 0. Now this d here is symbol of derivative. When this symbol d goes on the other side, it is represented as antiderivative. It is represented with an elongated s, often called as integral. F dash x stays here only, while this dx transfers here and it becomes here. So whenever you are doing integration, dx will always be in the numerator. While derivating, dx is always in denominator, while this remains as it is. So we can rewrite this as integral f dash x dx is equal to f of x plus c. This makes us understand that if you already have a function which is derivated, if you integrate it, you will get back the function again. Let's understand this again with some more examples. Say we ask you to find the derivative of x raised to n plus 1 upon n plus 1. To derivate this function, we will need to know that there is no need to do u upon v rule, as n plus 1 is already a constant in denominator, and x raised to n plus 1's derivative we know is n plus 1 into x raised to n plus 1 minus 1. 1 gets cancelled, even n plus 1 quantity is getting cancelled. So this implies that you have got the answer as x raised to n for dy dx of x raised to n plus 1 upon n plus 1. This therefore clearly implies, by the earlier definition, that if derivative is taken on the other side, you will get integration of x raised to n dx is equal to x raised to n plus 1 upon n plus 1 plus c. As if you would have even taken plus c here, its derivative would have been 0 here. Just take care of one thing, that n should not be minus 1, else the denominator will be 0. Based on this, there are many simple integrals which keep occurring frequently. Students are advised to learn them. Like one of their commonly occurring integral is 1 upon x square. So if you take this up, you will get x raised to minus 2, which on comparing with this formula form becomes x raised to minus 2 plus 1 is minus 1 upon minus 1 plus c is minus 1 upon x plus c. Students are advised to remember such forms for exam. To save time, let us take some standard derivatives directly. Say we have the standard integration given here. The first one is x raised to n, which we just saw a while back. Let's take the next one, 1 upon x. Now 1 upon x, if you would have taken it this way, then x raised to minus 1 would have happened, and we have already told you n is not minus 1. So we will learn this by learning derivative of log x as 1 upon x. So integral 1 upon x is log x. Log always operates on positive quantity, so we have written here mod. We'll continue. As we know, derivative of sine x is cos x. So integral of cos x is sine x, etc. plus c, and all the standard forms we have written here. Students are advised to learn them from derivative. As I told in the beginning of the video, our pace will be little higher, so I'm not making you write all of it. This you can learn or write it at home by your time, taking your time. Look at this one. Like students often have a doubt over a raised to x integration, how it is a raised to x upon log a. Recollect everybody, if you take derivative of a raised to x upon log a plus some constant c, then do not apply u upon v rule. Log a is a constant, so it will just stay down there. A raised to x derivative is a raised to x log a. You can now cancel log a. C's derivative is 0. So answer is a raised to x. Now take this derivative on this side, it becomes integration. Hence integral a raised to x dx is a raised to x upon log a plus c. The only condition is that a should be greater than 0, as you have log a in the answer. Remaining 1 upon root x can be easily learned with x raised to n formula. Students are advised to memorize this as it comes frequently. Integral dx या integral 1 dx is equal to x plus c. As x derivative is 1, integral of 1 is x. Sin inverse x derivative was 1 upon root 1 minus x square. Hence integral of this 1 upon root 1 minus x square is sin inverse x plus c. Or minus cos inverse x plus c. As you know, derivative of minus cos inverse x will be positive 1 upon root 1 minus x square. Similarly, one of the very important results, even this was very important. 1 upon 1 plus x square integral is tan inverse x or minus cot inverse x. 1 upon x root x square minus 1 sec inverse x plus c or minus cosec inverse x plus c. After learning these integrals, we will head towards some more integrals which are required. We'll finish all of them, and then in the next video we will start with problems. Let us take some more integrals. The next one that we have is integral of tan x. Now when you have integral of tan x here, it's written as log of mod of sec x. Now students always have a doubt over the results as to how they have been derived. For understanding this, for understanding these results, let us try understanding a basic formula to start the topic. Integral of f dash x upon f of x dx is given by log of mod of f of x plus c. How this comes, we will teach you in substitution method in the next video. In the meanwhile, if you observe this, we are trying to say here that if a function is there in denominator and its derivative is upside, the answer is log mod f of x. Take example, say we have 1 upon x. X derivative is 1, so it matches to this. Hence we try teaching you integration of 1 upon x is log x plus c or log mod x plus c. Let's now try taking example of integration of tan x. Now when you face tan x, the student can write tan x as sin x upon cos x. This makes you think that cos x derivative is sin x or minus sin x. So derivative of cos x, if it is minus sin x, you will have to make this minus, but there was no minus with you. So you can multiply with minus 2 times. So this becomes minus log of mod of cos x plus c. Why? Because if this is f of x, the numerator is behaving like f dash x. So the formula is log of mod of f of x plus c, which becomes in this case minus, which was this minus log mod cos x plus c. If this minus is taken in the degree, this becomes log of cos x raised to minus 1 plus c. Caution, this is not cos inverse x, it is cos x raised to minus 1. So this can be reciprocal and written as 1 upon cos x plus c, and reciprocal of cos x we know is sec x plus c. Hence we advise students to learn integral of tan x as minus log of mod cos x, or you can learn log of mod sec x plus c. Similarly, you can on your own derive integral of cot x by doing cos x upon sin x, and sin x derivative is cos x, hence log mod sin x. So these two are a little different ones. We have just covered them. Students are advised to learn them. Next is integral of sec x is log of mod of sec x plus tan x. And this on simplifying becomes log mod tan pi by 4 plus x by 2. We'll try deriving 18 as 19th is similar. Let's try deriving 18th for us. Let us continue with the 18th one. In the 18th one, let us copy integral of sec x. This is your question. If we multiply by sec x plus tan x in both numerator and denominator, then there is a chance of creating such kind of a result. This on multiplying in numerator becomes sec square x plus sec x tan x, the whole upon sec x plus tan x. Recollect, derivative of sec x is sec x tan x. Derivative of tan x is sec square x. So this is like f of x, this complete thing, while the numerator is like f dash x. So what did we try teaching you earlier? What did we try teaching you? Integral f dash x upon f of x is how much? Log of mod of f of x plus c. So here the answer would be log of mod of sec x plus tan x plus c. Hence this result. One more time, integral of sec x is log mod sec x plus tan x. Let's try to simplify this further. Let's try to continue writing this further. And in sec x is 1 upon cos x, while tan x is sin x upon cos x plus c. So this becomes is equal to log of mod of 1 plus sin x upon cos x plus c. This leads you to is equal to log of mod of 1 plus sin x formula student should know is cos x by 2 plus sin x by 2 the whole square, and cos x can be written as cos square x by 2 minus sin square x by 2 plus c is equal to log of the numerator is the whole square, while the denominator can be written in the form of x cos x by 2 plus sin x by 2 the whole square upon cos x by 2 minus sin x by 2 into cos x by 2 plus sin x by 2. We are able to cancel one of the factors, so we are left with cos x by 2 plus sin x by 2 upon cos x by 2 minus sin x by 2. Such functions we usually, or such steps we usually divide by cos x by 2. When you divide with cos x by 2 in both numerator and denominator, we get 1 plus tan x by 2 upon 1 minus tan x by 2. And we all know 1 plus tan x by 2 upon 1 minus tan x by 2 is tan pi by 4 minus x by 2 plus c. Hence, integral of this is positive here, so plus sign will come in the numerator. So integral of log of mod sec x plus tan x is also expressed as log mod tan pi by 4 plus x by 2. Similarly, for cosec x, students can multiply and divide by cosec x minus cot x to get this answer. And this on simplifying, as we tried doing in this case here, you can get log of mod tan x by 2. I hope this video helps you. Thank you for watching it.